Lokiceratops lived 78 million years ago during the Campanian stage of the late Cretaceous. The western interior seaway split North America into two land masses. The western strip, Laramidia, hosted lush wetlands, rivers, and floodplains. The Judith River Formation preserved crocodilians, turtles, amphibians, fish, and dinosaurs. The climate was warm and humid, with seasonal flooding. Floodplains and Oxbow lakes created isolated populations. Geographic isolation accelerated evolutionary divergence. Lokiceratops emerged in this ecological mosaic. The fossil was uncovered in 2008 in Kennedy Coulee, northern Montana. The site was nicknamed Loki Quarry. Preparation revealed a skull with long brow horns, no nasal horn, and lateral frill blades. The specimen was catalogued as MK0012. The species was named Lokiceratops rangiformis. Lokiceratops means Loki horned face, after the Norse trickster god. Rangiformis means reindeer-shaped, describing the antler-like arrangement. The holotype skull is displayed in Denmark. Casts remain in North America for research. The find became one of the most unusual ceratopsian skulls ever studied, instantly rewriting the picture of horned dinosaur diversity in northern Laramidia. Lokiceratops reached nearly 6.7 meters in length and weighed 5 tons. Its skull exceeded 2 meters. It was a quadrupedal herbivore with robust limbs. The chest anchored strong neck muscles to hold the massive skull. The beak was sharp and hooked, slicing through ferns, cycads, and magnolias. Dental batteries with hundreds of teeth sheared vegetation efficiently. The teeth were constantly replaced, ensuring continuous grinding power. Unlike most centrosaurines, Lokiceratops lacked a nasal horn. Instead, it carried long brow horns and hypertrophied lateral frill blades. The blades projected sideways, like scimitars. Too fragile for combat, they served display purposes. Covered in keratin, they appeared even longer. The keratin may have been brightly colored, flashing during movement. Males likely displayed them during courtship. Head swinging emphasized their extreme length. Brow horns, however, were sturdy and used in pushing contests. Lokiceratops combined weaponry and ornamentation. Its mix of long brow horns, absent nasal horn, and scimitar-like blades made it unique among ceratopsids. Northern Laramidia supported multiple centrosaurines simultaneously. This reflects extreme endemism. Each region developed unique ornament styles. Southern regions produced different species, while northern ones specialized in elaborate frills. Lokiceratops epitomized this trend. Its hypertrophied lateral blades exceeded anything known. Females selected mates based on ornament style. Each species developed a unique crest language. Populations diverged rapidly as sexual selection favored novel frill shapes. Lokiceratops became an example of runaway ornamentation. Its bizarre appearance was a product of both isolation and sexual competition. Compared to its relatives, Centrosaurus bore a nasal horn and short brows. Styracosaurus carried a crown of radiating spikes. Medusaceratops curled frill spikes outward. Spinops had hooked epiparietals. Albertoceratops combined long brows with a nasal horn. Lokiceratops broke the rules: long brows, no nasal horn, and extreme blades. The combination was unprecedented. The absence of a nasal horn, rare in centrosaurines, makes Lokiceratops crucial to understanding ceratopsid evolution. Its mosaic of traits shows experimentation within horned dinosaurs, blending functions in new ways. The environment of Lokiceratops was filled with horsetails, ferns, cycads, magnolias, and conifers. Hadrosaurs like Brachylophosaurus and Gryposaurus browsed nearby. Armored ankylosaurs trundled through undergrowth. Small predators like Dromaeosaurus stalked the edges. Crocodilians lurked near rivers. Turtles and gars swam in the waters. Lokiceratops herds browsed mid-level vegetation. Hadrosaurs stripped taller plants while ankylosaurs fed low. This division reduced competition. Herds shaped plant communities through heavy grazing, dropping spread seeds across floodplains, aiding regeneration. Lokiceratops played a role in maintaining ecosystem balance. Predators included Gorgosaurus and giant crocodilians like Dinosuchus. A lone Lokiceratops risked ambush near riverbanks. In herds, adults encircled calves. They lowered horns and flashed frills to deter predators. The spectacle alone could discourage attack. If forced, brow horns engaged directly. Lateral blades expanded the display, making the dinosaur appear larger. Cooperation between herd members ensured survival. This strategy mirrored behaviors of modern large herbivores like bison or muskoxen. Lokiceratops combined physical defense with social cohesion. Lokiceratops calves hatched from eggs laid in nests, scraped into soft earth. Hatchlings were small, with rounded frills and no hypertrophied blades. Juveniles grew rapidly, feeding on tender shoots. As they matured, frills elongated, blades only hypertrophied at sexual maturity. This delayed development suggests the blades were secondary sexual characteristics. Growth rings in bone show adults lived for decades. Mature individuals carried scars from horn clashes. Healed wounds on skulls proved ritual combat was common. Dominance was established through contests rather than predation. Hierarchy was reinforced by visual signals. Larger blades and battle scars marked experienced males. Females likely chose mates displaying both ornament size and survival strength. Lokiceratops societies revolved around these cues. The herd was not just protection, it was a social network shaped by ornamentation. Juveniles practiced sparring to prepare for adult contests. Like antlered mammals today, ceratopsians built identity around horns and frills. Lokiceratops was one of the clearest demonstrations of this evolutionary pattern. The fossil skull was heavily flattened by geologic pressure. Paleontologists used 3D scanning to image fragments. They mirrored preserved halves to reconstruct missing portions. Digital correction restored original proportions. The reconstruction confirmed unprecedented frill blades. Some researchers questioned whether it was a variant of another centrosaurine. Comparison with existing species showed unique traits: the absence of a nasal horn, the exaggerated lateral blades, and the chasmosaurine-like brow horns separated it. Consensus recognized it as a new species. Lokiceratops became a landmark discovery. Phylogenetic analysis clustered it with Albertoceratops and Medusaceratops, forming a northern ornate frilled group. Its brow horns resembled chasmosaurines, an example of convergence. The hypertrophied frill blades were unique to centrosaurines. This mosaic illustrates plasticity within ceratopsids. Lokiceratops demonstrates how isolation and sexual selection could create new combinations of traits in just a few million years. Its evolutionary experiment added another branch to the ceratopsian tree. Supporting a 2-meter skull required powerful neck muscles. Expanded frill surfaces provided anchor points. The frill redistributed stress during horn clashes. Brow horns locked in pushing contests. Lateral blades amplified visual profile without being practical weapons. Keratin sheaths strengthened surfaces and could repair minor damage. Evidence from scars suggests frequent fighting. Lokiceratops carried the marks of combat. Frill injuries healed over time, leaving bone thickening. Survivors bore visual testimony of dominance. The skull became both weapon and record of life history. The blades functioned as honest signals. Only healthy individuals could sustain such extravagant growth. keratin coverings may have displayed vivid colors. Lateral head swings emphasized length. In sunlight, the effect would have been striking. Modern parallels exist in peacocks, deer, and moose. Lokiceratops shows that dinosaurs also engaged in visual communication. Sexual selection was as powerful as predation. Social signals governed reproduction and hierarchy. Lokiceratops embodied this principle, proving natural selection worked through communication as much as combat. Mounted skeletons allow appreciation of its scale. Replicas in North America support education. Students learn from its dramatic appearance. Lokiceratops shows evolution favoring spectacle. Ornaments reveal natural selection through social interaction. Visitors confront a skull larger than themselves. The scimitar blades capture immediate attention. The name Loki emphasizes trickery and strangeness. The dinosaur becomes a museum centerpiece. Its story bridges science and culture. Unanswered questions remain. The coloration of frills is unknown. Sexual dimorphism is uncertain. Males may have carried larger blades. Juveniles are absent from the record. Growth sequences remain incomplete. Keratin extent is speculative. Future fossils may provide clarity. New discoveries could reveal behavior and herd structure. The mystery keeps Lokiceratops in scientific discussion. Each field season holds the chance of filling gaps. Lokiceratops proves ceratopsians diversified explosively. Northern Laramidia produced ornament signatures. Mate choice and isolation drove variety. Ceratopsians branched into flamboyant experiments. Lokiceratops exemplifies this burst. Lokiceratops lived and died 78 million years ago. Its skull recorded communication and competition. It grazed in wetlands, herded together, and defended with spectacle. Its discovery reveals that survival was not just about eating and avoiding predators. It was also about impressing mates and intimidating rivals. Compared in detail with relatives, Centrosaurus had a nasal horn and lacked long brows. Styroscosaurus created a crown of radiating spikes. Medusaceratops twisted epiparietals outward like snakes. Albertoceratops combined nasal and brow horns. Triceratops, much later, carried both long brows and a short myrtle horn, but no lateral blades. Lokiceratops combined long brows with hypertrophied lateral blades and omitted the nasal horn entirely. This arrangement was unmatched. The absence of a nasal horn in a centrosaurine is a rare reversal. The hypertrophied lateral spikes represented evolutionary compensation. Lokiceratops restructured its display system. This deviation demonstrates flexibility in horn evolution. It breaks the assumption of a fixed centrosaurine plan. Lokiceratops stands as an icon of evolutionary experimentation. Lokiceratops shared its ecosystem with giant predators like Gorgosaurus. Smaller predators such as Dromaeosaurus harassed juveniles. The looming danger of Dinosuchus haunted riverbanks. Despite this, the greatest battles Lokiceratops fought were against its own kind.